I'm starting a new series, Numerical Method for Solving Systems of Nonlinear Equations by Courtney, Remani, Lakehead University, Ontario, Canada. In Chapter 3, we will learn Newton's method to solve system of nonlinear equations. In the process of solving system of nonlinear equations, we need a Jacobian matrix. We also need a partial derivative. More specifically, we will solve this system of nonlinear equations. If you are interested, please keep watching my videos for system of nonlinear equations. Hi everyone, my name is Thomas Kim. Today is April 8th, 2021. This is my first episode about numerical methods for solving systems of nonlinear equations. To solve system of nonlinear equations, we need numerical partial differentiation. For partial differentiation, we need to implement a function called fixed arguments other than n's. Just so you know, in my Korean channel, in this video, I demonstrated how to solve a system of nonlinear equations, but I haven't filmed how to implement. So, through this new series of videos, I will explain how to implement algorithm for solving systems of nonlinear equations. First off, you have to know how to do numerical differentiation using 5-point stencil algorithm. If you want to know how to implement numerical differentiation algorithm using 5-point stencil and Taylor series, please watch this video. Without understanding numerical differentiation, we cannot solve system of nonlinear equations. Numerical methods for solving system of nonlinear equations by Courtney, Remani, Lakehead University. Please double-click this link. Then you can download this PDF file. We also have to be able to solve system of linear equations. From FFT tutorial 06, please double-click this link. In this video, the complete FFT, I explained how to implement fast Fourier transform algorithm. In this video, show more. In the download source code section, please double-click this link. We need some source code from this episode. Also, if you need Thomas's calculus early transcendental, you can double-click this link and download Thomas's calculus. We will refer to this book for partial derivative. From Newton method, 5-point stencil, Gaussian quadrature, please double-click this link. In this episode, I explained Newton method, 5-point stencil, and Gaussian quadrature. Show more from the download source code section. Please double-click it. Now, show in folder, unzip it. Also, unzip it. Create a new folder, 01, partial derivative. From FFT folder, we copy two header files. Copy, move up, 01 partial derivative, paste it here. Go up, from Newton method, we need talk play fun, vector.hpp, copy, go up, in folder 01 partial derivative, paste. Now go up, select all, unselect 01, delete. Copy this folder, copy. In your working drive, I will create a new folder, System of Nonlinear Equations. I created a new folder. Double click it. Paste. Now copy the folder path. Right click. Properties. In the starting, paste. Apply. Click OK. Right click, properties, paste. Click OK. Right click, properties, paste. Click OK. Now go up, right click, pin to quick access. So we have this folder in quick access. Copy this folder once again. Now start Visual Studio Code. File, open folder, paste. Select folder. Select this folder. Click this button. diff.cpp. Hit enter. Double click, Control B. You will see squiggle. Also, you will see squiggle. Control Shift P. Edit configuration JSON. Or open C properties JSON. Here, quote dollar include curly brace / 2 comma. Here we need C++20. With this, now squiggle disappeared. We can close this file. In the talk play fun fft.hpp, second edit, April 08, 2021. Here include talk play fun std extensions.hpp. Here include talk play fun vector hpp. Scroll down. Here namespace TNA talk play fun numerical analysis. This namespace is defined in talk play fun vector.hpp. talk play fun vector.hpp. In this file, you can find the namespace numerical analysis. In this file, we don't need use math defines, but we need concepts. Now close this file. Close this file. In .cpp include talk play fun fft.hpp, talk play fun stream oro and talk play fun and copy paste and L and L. Also oro and L talk play fun and L copy paste and L and L. For the test differentiation, copy the function name int main, paste. Here we create a function orof, orox. Don't miss semicolon here. Return std sin x. Oro pi over 4 numbers phi over 4.0 or sine d phi over 4 we differentiate TNA DIFF stencil we pass phi over 4 then our function f semicolon we differentiate SDD sine x at phi over 4 or 45 degrees. String df over dx at phi over 4 sine d phi over 4 we compare with SDD cosine phi over 4 and there. Now start command prompt dir cd 01 partial derivative dp cpp q sdd c++ 20 f no sickle ehsc diff.cpp tbb mall oc.lib o d.exe hit enter. Sorry, in this file I have to delete. We build again CLSD. Please note that we differentiate sine x at phi over 4. The result is the same cosine phi over 4. The same. So our DIFF stencil works correctly. I will copy the command line. Copy, paste it here. Ctrl B. Now we test using Microsoft compiler CD01 partial derivative CL EHSC SED C++ latest diff.cpp tbb malloc.lib fe m.exe hit enter. CLSM Microsoft compiler also works. I will copy this command string, paste it here. Now with the Clang compiler CD01 partial derivative Clang++ SED C++ 20 diff.cpp ltbb ltbb malloc o c.exe hit enter. Our Clang compiler also works. I will copy this string, copy, paste it here, paste it here. We can use the same command for GNU compiler too. If we test with the GNU compiler, hit enter. GNU compiler also works. Now, right-click, go to definition. The value type x is the argument of this function. Here, requires, open, curly brace, we are calling f by passing x. Its return value should be std convertible to value type. This is concept. Copy, paste. Here, I will cut, paste it here. This part is the same. Now, we call this function by passing x, f, and h lower, h higher. we have to change the order like this. Now in this function, I will disable it, copy, paste, F. I changed the order. Now we build again using Intel compiler. 172, return. We build again CLSD using Clang compiler. Clang compiler also works. Using Microsoft compiler. Microsoft compiler also works. In this episode, I originally planned how to implement partial differentiation, but this episode became too long. In my next episode, I will implement partial differentiation.